Hello, this is the intro video to section 9.2. We'll call it the 9.2 exploration. Okay, so we're going a little off notes right now, so I want you to go ahead and pause this video and grab a sheet of paper to take notes on. We're actually just going to take notes on a sheet of paper for this beginning part. Okay, our 9.2 exploration. In section 9.2, what we're doing is that we're expanding on our idea for 9.1, that Pythagorean theorem idea, that a squared plus b squared equals c squared in a right triangle, and we're going to apply that to some special types of right triangles. So basically we're going to look at two special types of right triangle. The first one, two special types of right triangle. The first one is an isosceles right triangle. So we want an isosceles right triangle. I probably spelled isosceles wrong. Okay. So we know the hypotenuse is always the longest side. So if it's isosceles, that means its legs have to be congruent. So I'm going to take my template and I'm going to draw one here. I'm going to draw it from the square. Okay. So I'm going to start here with this square, and I'm just going to draw the two sides of this square. So one side, two sides, to make that 90-degree angle. So really what I've created here is a 90-degree angle and two congruent sides. And then I'm going to connect them with my hypothesis. Okay. So here I have an isosceles right triangle. Okay. What's interesting about this isosceles right triangle is, okay, so here's our legs, is first of all the legs are congruent, the two legs. Here's our hypotenuse. Okay. And we even know some special things about these angles, because these two angles here are congruent by the base angles theorem. If two sides of a triangle are congruent, the two angles opposite them are congruent. And if all the angles have to add up to 180, and this one's a 90, then I know these two are both 45 degrees, because they have to be half of the other 90. So here we have an angle, a triangle with two 45-degree angles and one 90-degree angle. Okay? So what we're going to look at is we want to look at the relationship between the legs and the hypotenuse here. Well, we know if I take the legs and square them and add them, it should equal the hypotenuse squared. But these two legs are always the same. So if this one is x units long, so is this one. These two legs will always have the same length. So let's let their length be x. And so now I want to come up with a way of relating the hypotenuse to these two legs. Well, we know that leg squared, so x squared, plus leg squared, x squared, has to equal the hypotenuse, let's use h, hypotenuse squared. So I have an x squared plus an x squared. Really, that's two of them. I have two x squareds equals my hypotenuse squared. Okay. So both of these are squared. So I'm going to, if you remember this from Algebra 1, I'm going to square root both sides. So this means I'm taking the square root of 2 times the square root of x squared, and then I get the square root of h squared. Well, the square root of x squared is just x. The square root of 2 is 2, so I have the square root of 2 times x equals, and the square root of h squared is just h. So here, what I've come up with is that this hypotenuse is going to be equal to the square root of 2 times the x. Well, the x was the length of the leg. So the hypotenuse is going to be equal to the square root of 2 times x, where x is the length of the leg. Okay, so that's kind of interesting. So what that means is I'm going to draw another one over here, but actually put some numbers in it. So use the two sides of my square. If I know that I have an isosceles right triangle, this side's congruent to this side, okay, I only really need to know one side. Like if I know this leg is 5. Well, since it's isosceles, I know this leg is 5. And I know that the hypotenuse is going to be equal to the square root of 2 times that 5. So this hypotenuse is going to be equal to the square root of 2 times the 5, which we tend to write that as 5 square root 2. So I know the length of that hypotenuse. I don't even need to do the Pythagorean theorem. Okay, this is a shortcut. Really, it's a shortcut rule. Okay, and we'll discuss it in more detail in the actual notes. Okay, so this was our first type of right triangle, was our isosceles right triangle. Okay, our second type of special right triangle, we're actually going to start with an equilateral triangle. All the sides are the same. So I'm actually going to start with an equilateral triangle, and you have a nice equilateral triangle on your template. Most of them do. So we'll do equilateral triangle right here. Okay. So all the sides are the same. Okay. So this doesn't have a right triangle in it. Okay. So let's put a right triangle in it. What I'm going to do is I'm going to draw in the altitude. Okay. So here's our altitude, which makes a 90 degree. So now I've actually created 2 right triangles. I'm going to go ahead and I'm just going to highlight one of them. Let's look at this guy right here. Triangles, there's just the one of them. Let's label these so we can talk about them. A, B, C. Okay. Okay, what's interesting about, if you remember from our section on altitudes, medians, and angle bisectors, is in an equilateral triangle, the altitude is also the median, which means that this goes through the midpoint. So that tells me this piece is congruent to this one. And it's also the angle bisector, which tells me this angle is congruent to this one. Okay. Right. So I know, since this is an equilateral triangle, if I'm looking at the whole big triangle, A, B, C, let's put D right here. What was that point? If I'm looking at the whole angle A is 60 degrees, because it's equilateral. The whole angle C is 60 degrees, which means each of these little ones up here would have to be 60 divided by 2, so each of these would have to be 30. 30 degrees and 30 degrees. You can see in there, those are both 30s. Sorry, that's kind of tiny. Okay. All right, so let's go ahead and let's look at the measures on this one. Okay, to help us figure out, I'm going to actually put some numbers because I think numbers will make this one easier. I'm going to say each side's 4. I could pick whatever number I want. Each side's 4, which means that each of these little pieces is going to be 2. Okay, so I basically know everything. This side's 4, this little piece is 2. So if we blow up, I'm going to draw a bigger picture of that just orange half of the triangle. So here's the blown up of that orange half. I'm just blowing up D to B to C. We have a 90 degree angle here, so there's our 90 degree angle. So this side over here is our hypotenuse. But we said, hey, let's make that 4. Okay, and then now here's our 2 legs. If you notice here, we have a short leg. Here's the short one, right? It's a shorter one, and here's the longer one. So here's our long leg. Okay. We had the short leg from D to C was 2. So if you notice, the short leg here is half of what the hypotenuse is. But we haven't figured out what this long leg is yet. So let's find that out. This long leg, let's have that be our lowercase x. So I can use the Pythagorean theorem here. A squared, so x squared, plus 2 squared equals 4 squared. Okay. So x squared plus 2 squared is 4 equals 16. Subtract the 4 from both sides. X squared is going to equal 12. And then we need to square root both sides. So x is going to be equal to the square root of 12, which 12 divides up into 4 times 3. So square root of 4, square root of 3. So 2 to square root of 3. Well, if you notice, the 2 matches this 2 right here. Okay, but the only thing we're doing is multiplying by that 2 by the square root of 3. Okay, multiplying the 2 by the square root of 3. So this side would end up being 2 square root of 3. So we have a bit of a pattern here. The short leg here is half the hypotenuse. So if I take the short leg times 2, I get the hypotenuse. If I take the short leg times root 3, I get the long leg. Okay, nice little pattern there. Okay, we're going to give a more formal explanation of that pattern. Okay, in the actual notes for 9.2. Okay, so let's go ahead, put this sheet in your notes, and let's go on to the next video.